Okay. So 1 second, we have to say this. Yeah. Okay. What we are going to understand, study today, that is what is called molecular orbital theory. Molecular orbital theory. Orbital theory. Have you taken the breakfast? Sanoy
Yes, sir.
Bhattacharya.
Sir, audible, audible.
Okay, okay. So what we have to do? Given by who gave this theory? Given by Hunts, Hunds, Hunts. The same Hunts multiplicity rule is there, na same one. Hunts and Mulligan. Mulligan, who was the Mulligan? Same Mulligan was there. Those who searched the that is what is called neutron. He searched na, that is oil drop experiment of Mulligan. So,
Mulligan and salt drop experiment. Yes, sir, I remember.
both are the same one. Both are the same. Now, see the given to why this is given to explain the paramagnetic behavior magnetic behavior of O2 oxygen molecule. Oxygen. See if you are making the O2 molecule, O2. So we are having the oxygen and oxygen 2,6. 2,6. If you are making the 1s2, 2s2, and it is going to be 2p4 something. And here is 1s2 and 2s2, and this is also going to be 2p4. Now you make it, label it. Here is 1, 2, 3, and this is the 4. And similarly, what is going to happen? 1, 2, 3, and 4. Now they are overlapping. How they are? If they will overlap together, so what will formed? They get pair. Okay, they get pair because suppose the any pz. So
PY
I
and PZ are doing.
they are there na. So what will happen? Here there will be the pairing na. The electron will be pair, so that the bond will form. If they will not pair, how they can form? 2 electron required for 1 bond. So they get paired. So they get paired means there is no unpaired electron. If they are going to pair, there will not be any unpaired electron. Yes or no?
Yes, sir.
So that is the compound should be all paired. It will be the all paired electron. All paired electron. So it means compound should be what? This compound should be what? Compound should be diamagnetic. Compound should be diamagnetic. Yes or no? Compound
Yes.
diamagnetic. Right. This compound should be diamagnetic because it repel in the magnetic field. Repelled in magnetic field.
Magnetic field, yes, sir.
But what is happening? But experimentally, it is paramagnetic. But it is paramagnetic. So all theory fail. Whatever the theory are given, that is they failed. They could not explain. Whether it is the concept of hybridization is there, valence bond theory are there, they all failed. Okay. So that is paramagnetic character is explained by what? MOT, molecular orbital theory. So why this theory is given? To explain the paramagnetic behavior of what? That is the oxygen molecule.
O2 molecule.
O2 molecule or O2 type of molecule. Okay, O2 molecule. Right. Can I erase?
Yes.
Okay.
Yes.
I'm recording or not, that I need to check. Yeah. So this is now. What we are going to do, Sanoy, now postulates of MOT. Few postulates are there that you need to find out. First one. Okay. What is the first one? Atomic orbital. This is atomic orbital combines to form combines to form molecular orbital. What they are forming? Molecular orbital. Okay. Till now, there was no concept of molecular orbital. Now it is coming the concept of molecular orbital. They are saying as many number of AO means atomic orbital combine as many number of AO combine that
That
many
many number of molecular orbital are formed.
thank you that many molecular orbital formed. Third, as electron is present as electron present in electron of wait as electron of atoms present in atomic orbital AO. Similarly, electron of molecules present in where? Present in molecular orbital. Okay. Fourth, if I will talk about when two AO combine then two but forming MO formed. The one is what they are coming. The one is bonding molecular orbital. The one is bonding molecular orbital. One is bonding molecular orbital. That is what is called BMO, bonding molecular orbital.
BMO and ABM.
And other is
Antibonding.
This chapter taught by Akash Institute.
Sir, Akash, when this chapter was being taught, then I missed some classes, but it is taught in our school. This MOT is taught in our school.
And anti-bonding molecular orbital. That is what is ABMO.
Yes.
Okay, next one. ABMO is having more repulsion, more energy. ABMO is having more energy than BMO. Okay. Is it okay?
Yes, sir.
I'm erasing the point, some point also here to write some more point.
Sir, I have noted everything down. You can erase everything.
Okay, thank you very much. Okay. Now the next point, I think 7 point. It is there. BMO. BMO is formed by 6-1. BMO is formed by constructive
Interference.
Constructive overlapping. I am writing overlapping of atomic
Both are the
orbital.
same only, no?
Both are same. ABMO also same.
No, sir. Sir, I am asking that constructive overlapping and constructive interference are same or different?
Same. In phase overlapping, out phase overlapping. ABMO is formed by
destructive overlapping.
It's formed by destructive overlapping. Overlapping of orbital. OBER LAW. Overlapping of orbital, of atomic orbital. Any other point which we are missing? Yes, no. No. So what is the constructive overlapping and what is the destructive overlapping? Can you please tell me? Hello, sir. No.
Sir, constructive overlapping is, sir, like this. One second, just.
One more point is I am remembering one more point. Can I write one more point? Okay.
Yes, sir. Yes.
BMO results in Wait. Not that is. That way we cannot write. See, S orbital, then S orbital and PZ orbital. S orbital and PZ orbital. What they are going to form? Formed
Sigma bond.
sigma bond. And PX, PY, they are forming, that is what? Pi bond. So this will be the okay. This much only we have to understand. Tell me are you telling next page you can take? Tell me constructive and destructive overlapping.
Sir, constructive overlapping means like, so this is one wave, this is another wave. Sir, they both are joining to form a bigger wave like this. The
And whatever.
destructive overlap, this is one. Okay, correctly, you know. So, see, this is the atoms are there, na? Atoms is spin of the atom. Suppose combination of heading I'm writing combination of atomic orbital to form molecular orbital is done by what method? Is done by LCAO method. What is LCAO method, Sanwa? Sir, linear combination of atomic orbitals.
So that is what the constructive destructive are there. Suppose this one is there and it is having the plus spin, and another orbital is there, S orbital, it is also having the plus spin. This is 1s. So these both are going to be in phase. Why? Because it is also having the same and it is also having the same. Okay, so this is what they are going to combine. What they are going to form? They are going to form the molecular orbital overlapping, and after overlapping, what is the shape it is going to come if you are making this one? Let me draw it like that. This one, bonding molecular orbital, or this is the represented in some other book if you are going now. So how they represent? Simple. There are many way of representation. This is when the atomic orbital combined, they form the molecular orbital, and that time the atomic orbital identity of atomic orbital lost. So here is the 2 electron we can represent. This is, or one more way is there. That much only, the two you try to understand, that is enough. Okay, can you understand?
Yes, sir.
Okay, so this is, so the in this case electron will be quite closer. I put it because they are forming the bond pair now, so that will be electron will be closer to each other. Now let us see the second one. Suppose this is the S orbital, this is the 1s, and this is the 1s, but here the rotation is, one is the clockwise plus and another is minus. Okay, plus and minus. Plus means, do you know this is what do you mean? If I am representing something plus means the wave, you know, this will be the psi plus and psi minus. Okay, so psi plus means this is the all will be the same one, and here is also this is the one. So if you are adding this one, so it will give the bigger level like this. But if you are psi minus, destructive, if you are talking about destructive, the case of destructive, one is the same, and second one if you are joining, so what it will there? It will be the opposite of this. It will be opposite of this. So that is the out phase is there now. So this case, the what is the resulting wave will be like that. Because here you see the crest and here is trough. Though they will combine, the what will come? Here the psi plus, here is psi minus. So it will be that is psi. So whatever is forming, that is it will be the less will come. And here is the in this case, here is psi plus. So both will be what? Psi A, psi A plus psi B. Here is psi also plus. So resulting will be psi A plus psi B. Psi result is equal to what? Psi A plus psi B. Yeah, psi plus plus psi plus. So it will be the in phase. Can you understand this one?
Yes, sir.
So
Sir,
here is
INPH.
what?
So that in phase spelling INPHAC.
In phase. Okay, here. So here it will be destructive. So that is atom is going to be away, not going to be the nearer. So what the shape? Either you simply you write here the electron will be there, and one will be the here. Okay, here. So there is the distance is there. And how you can make the diagram if you are making the structure? So this will come like that. Here. Means in this case, electron is going away. Here is electron and here is electron. So this is what is called bonding, BMO. And this is called in ABMO. So it is going to form the sigma. Okay, sigma bond. So represented by sigma 1s. And how many total electron is there? So sigma 1s2.
2.
And here is anti-bonding is
Sigma
represented
star
by,
1.
thank you very much, sigma star 1s2. Okay, is it okay?
Yes, sir.
Now let us for the p orbital. P orbital. You know p orbital, pz orbital are the along the nuclear axis. So that is firstly pz. So I am talking about pz and pz. So pz, how they are combining. So this is the pz. There are two possibilities are there. One will be the in phase, another will be out phase. So suppose plus plus is there, na? So it is going to form the this type of orbital. What to call? Overlapping will take place. See, different book, different you will find. So here, this is the bonding. Okay. So it will be sigma 2pz. It can be the 2. Now, if you are this you can plus and this is minus. This will be the different their waves are going. Okay. So if you are making this one, how can you make? They are going to be away from each other, na? So let it be like that. They are not going to come closer. And here the one lobe will is going to be smaller one. Let me tell again. Let me draw again. This one. One lobe is going to be smaller, another lobe is going to be. So
Sir,
this
why
way,
this one is getting smaller?
after combining, they mix now. So if they are
Okay.
mixing, due to mixing, this is happening. So this is what the one is going to be plus here, and another is going to be minus. So because the plus minus, it is not the charges. Getting my point. This is the wave.
Yes, sir.
This is the phase of the wave.
Wave.
Phase of the wave. Okay. Now the last one for 2px or 2py. Yes, yeah, no. 2px or 2py. So here what you can be. That is also there is possibilities, or let me write for 2px and 2py. So for both, I am doing the same diagram. Kindly try to understand. Here, this one. Okay, this is. So if you are talking about the, here it can be the plus plus, and here can be minus minus. Okay, one side plus means another side it is automatically going to be the minus. So how it is going to formed if you are talking about. So we can represent many way our representation is there. Kindly when you read the book, do not get confused. Okay. So overlapping will not be there. Proper overlapping is not there because they are going to form the pi bond. So this way, plus plus, minus minus. And if you are talking
Sir,
about
the
this,
downside there is no overlapping.
no, when pi bond is forming means the up and down, both the overlapping will be there, na?
Sir, but this area, sir, you have not made any overlapping. This
No,
one.
no, overlapping is not there. Here also overlapping not there because overlapping is not possible. Just simply they attach. Simply they attach. That is why it is
Sir,
very
then
weak.
like
Na?
this.
Ah,
This is one.
yeah, simply attach. Yeah. Correct.
Sir, but they will have zero overlap.
Pi bond is having very less overlapping, na? Very least overlapping. Like my hands are there, na? This is only touching each other. That is why it is getting separated each other. But if it is tightly bounded like that sigma bond, you can't separate it. That is why pi bond is very weak bond, na? Very reactive because there is no overlapping. If there is overlapping, can you separate? You can't separate that one. Okay. Now, that is what the concept. Something there is the logically we have to understand. Even there is overlapping very less. See yesterday what we are doing. Carbon are there, na? For the C2H4. So sigma bond is okay. Now you see the pi bond, how far they are? How far they are? Can they overlap? Can they overlap?
No, sir. No,
So
sir, they are
same,
not overlap.
only attraction is there, na? Kind of
Sir,
attraction.
maximum it can happen that they will be bending like this one. This will also bending like this one, and will touching each other only.
Touching or little bit overlapping. There is touching or maybe there is overlapping. Now see the quantum mechanics came now, quantum theory came now. So many things are filled. Many things are filled. So we are guessing that is the little bit overlapping. Little bit overlapping. You can make little bit overlapping. That is not possible. That is not problem. Little bit overlapping, no problem. Here you see, Sanoy, this case, what will be there like that? This is the repulsion. They are formed by repulsion because more energy means high repulsion. How they are forming? This one. So here is a plus, minus.
Sir, at the middle, they will be touching or they will not be touching?
They will be touching. They will be touching. Or they may not be touching. That is also not much information is not there on about that. They may not be touching also. There is no more information. Experimentally, how they observe the shaded region. So it is imaginary. Here they have given. So no, they did not say anything about the touching or not touching. They did not say. Here nothing is said about whether they are touching or not touching. Because they may not be touching also. That we cannot guarantee anything. Got it this much?
Yes, sir.
Okay. So energy level diagram. Energy level diagram. Energy level diagram. Okay. So what is the energy level diagram? This is the energy level for H2. Suppose I am going for H2. For H2, right? So I am having the H2, how it is forming? H2. So when H atom, okay, H atom, atomic orbital of H atom plus again atomic orbital of H atom. Okay, so they are combining. So molecular of orbital of what is forming? H2 molecule forming. Molecular orbital H2, right?
Yes. Sir, in our school, sir, that like some electronic configurations of the molecules, sir, we have to do.
Yeah,
Sir,
yeah.
that one also, sir, that area is not very clear with me. So, sir, can you please clear that one?
What? Please tell me. Electronic
Sir,
configuration.
yes, sir, electronic configuration of molecules like this form, delta 1s2, delta star. This
That is
form.
coming now. Why you are worrying? That is coming. See, this is the energy level. Energy level. Right? This is upside. This line representing atomic orbital, this line in atomic orbital, and this center is representing molecular orbital. Okay. When two atomic orbital, suppose it is what is the hydrogen, this is having the 1s1, and this hydrogen is also having 1s1. So this is what is 1s1, and this is also 1s1. So there's two s orbital combining, yes or no?
Yes, sir.
So what they are going to form? Two molecular orbital. Okay. So this is two molecular orbital. S orbital combining, so it will form the sigma bond only. So sigma, and it will be the sigma anti-bonding. High energy means sigma star. Is it?
Yes, sir.
Okay. So total electron here is one electron, one electron. So energy gap is very large. So it will electron will get paired here, two electron. So what will be configuration? Sigma 1s2. This is what configuration. And here is sigma 1, sigma star 1s0. No electron is there. So if you
The
are
diagrams have been covered in our school also, but sir, there it is a little bit different. Sir, can I send you one photo of how they did in our school, sir? You can understand it.
molecular
So can you
orbital.
just wait a minute, sir? I'll be sending a photo right now only.
MOC. Oh. I did not receive till now.
Sir, just one second. I'm clicking the photo, sir. You will receive it. Sir, it has gone.
Yeah, I
Gone.
received. Okay, this is for the C2, na. This is not for H2. I'm
Sir,
just
this is for O2, O2, not C2.
that is for O2 and N2. There is different diagram. Okay, keep in mind. I am starting from the basic now. What you
Sir,
will do?
actually, these two look different, sir. That is why I thought I will show you. That is why, sir.
No. This. Acha. They are not the difference. The way of the teaching is different. That is not different. No. Nothing is different. Acha, simply they are not making the box for the molecular orbital. They did not make the box. Other thing are the same. Sigma 1 SO2 sigma.
Sir,
No,
box
son.
was made outside.
Here, what you wrote, atomic orbital S2. Why you
Sir, box
paired?
still.
How you will get the? Acha, this is different now. See, let us go the step by step. We start from the hydrogen and go to the that is neon. So it is the directly they have given. No, that is not. We have to
Sir,
go.
molecular orbital diagram of N2 and H2, N2 and
O2.
O2.
N2 and O2, there are two different types are there. Getting?
Achha.
For that
Yes,
is for the 14 or more than 14 electron. Na? Below 14 up to 12, that is the same. Up to 12, that is what the same. There is no exception in the up to 12. This will be. So, okay. You will be able to know what I am teaching. So their bond order is 1. That is, you see, H bond H. Now, some characters I wrote here, you see, what are the characters? Can you see the characters? See, here one electron is there, one hydrogen atom, one electron, two electron. Two electron according to Hund's rule, they get pair because the energy of sigma 1s2 orbital is very less than the atomic orbital. So they get pair in here. So configuration become the sigma 1s2. And here is sigma star 1s2. Did you check?
Yes, sir.
Did you understand this concept?
Yes, sir. Sir, please wait 1 minute, sir. I am noting this diagram. Sir, done.
Okay. So, what is the bond order, Sanu? What is the bond order?
Sir, half into number of bonded minus number of bonding minus number of anti-bonding.
Okay. Magnetic properties, we have to see if there is no
Sir,
concept
if
of
it is fulfilled, then sir, if it is fulfilled, for example, here we are having just 1 second, sir. Uh, sir, here we are having this sigma sigma 1s2. So since it is fully filled, then it will be diamagnetic. Sir, if we had sigma 1s1, then it would be paramagnetic.
So now, okay, good. You draw for the He2, and find the bond order. You have to find magnetic properties, MOC, molecular orbital configuration, energy level diagram. These things you do.
Sir, He2 does not exist only, sir. How can I write all this?
That is, you have to explain on the basis of molecular orbital theory that why it does not exist. According to molecular orbital theory, you need to explain why it does not exist. Because how much bond order will come? Should I tell or you are trying?
Sir, bond order He2.
If the bond order is 0, then molecule will not exist. Very good. Zero. So no bond is there. Okay. He2 plus. Paramagnetic. Okay. Stanoy, for next class, I will teach you what that is BE2, B2, C2, N2, O2.
Sir, Be2 I can do now only, sir. Be hydrogen lithium beryllium. Sir,
Very
Be2 means 8 electrons. So this will be diamagnetic. Bond order is 0, therefore does not exist.
Good. Diagram. What will be the diagram?
That does not exist, then how can we make the diagram?
With the help of diagram only you are saying that does not exist.
So I am saying from the bond order.
Bond order you are saying that is okay. But that you have to show, na? That is how, where the electron are there in the bonding orbital, where the electron are there in anti-bonding orbital. Okay, do it for C2. Will C2 exist or not?
6. Sir, this is also having bond order 0 only, na? How can you make this?
Total 12 electron. 2 to 4 to 6 to 8 to 10 to 12. And this is also having bond order 0. So means the diagram will be there. Yeah, diagram is there. Energy level diagram is there. So it will be the
Sir,
what?
diagram can you show once how to make for these things?
For C2. See? Carbon is there, na? Carbon, carbon. So carbon is 6, 6. Atomic orbital 1s2, 2st, 2p2. Here is 1s2, 2s2, 2p2. Okay. So here the s orbital combining. So 2s orbital combined. So it forms. This is. So this is what? Then it will combine 2s. This is 2s orbital for 2s. This is 1s orbital because energy level of the 2s is more than the 1s. So here is this is also 2s. So this is. Now we are having the 2p. Here is 3 orbital are there, na? 3 orbital. This is the 2p and this is also 2p. So what is going to come here? The 2 1 2 1, na? Here will be the 2. This is 1. Okay, this is the this configuration is below the what? This configuration is for up to which atom? Below the up to nitrogen. 2 1 2 1. Up to nitrogen. B2, C2, N2, right? Up to nitrogen. When you are going for the oxygen, na, when you are going the oxygen, this reverse down one is this 1 to 2 1 1 2 it become. For oxygen, I will teach you in the next class. Up to here you see. Okay. So here you fill the electron. Here is the 2
In
electron.
our school also, sir, the same thing is drawn, but the just pattern is like this. Sir, there the boxes are being drawn outwards. This will be like this. This will be like this.
No
Here
problem,
in
yaar,
the
no
form of
problem.
circles only you have to give.
No problem, no problem. So here is this is now our this one is going to be over. This automatically it is going to disconnect. So how many? 2 to 4 to 6 to 8, 10, 11. How much? 2 to 4 to 6 to 8, 9, 10, 11, 12. So see, bond order if you are calculating the bond order. So how many bonding electron? This is the sigma 1s2, sigma star 1s2. So what the bond order you are saying that is not correct. Sigma 2s2, sigma star 2s2. This is what? Pi 2px2 equal to pi 2py2. So what is the bonding electron? 1 by 2 bonding electron you see. The bonding 2 to 4 to 6 to 8. 8 bonding electron minus 4. So 8 bonding means it is coming to be 2. So there is the 2 bond are there. And this is going to be diamagnetic. Diamagnetic. See 4 bonding electron here to 6 to 8. Anti-bonding only 4. So how you was saying that is 0? You cannot say na. You should know the diagram first. Can you understand this one?
Yes, sir.
So next class we will be on the Saturday, most probably on Saturday, otherwise we'll take on Sunday.
Yes, sir. Sir, I will call you on Saturday.
Okay. You just put the message, no? So I will be
Yes,
able
sir.
to meet. Okay, dear. Okay. Take care. Bye bye.
Thank you, sir. Thank you, sir.